Cheers.
Cheers.
To, I don't know, math?
Just a math and friendship. First we shake and then drink up.
You thought of starting a new career as a bartender, maybe?
I don't know.
Tony, what do you do?
Teach math at Cal State. For teaching, it's mostly an area called abstract algebra or number theory.
I remember I met you at that like drawing meetup.
Yeah.
Art and painting, and he's doing singing and music lessons, and he's into mixology and all these cool drinks he's learning how to make. But you teach math. And I'm like, wait a sec. So thank you
cool.
for being like representative of mathematicians as like cool people.
Well, thank you for calling me cool.
Yeah,
cool people.
absolutely. You meet somebody new and,
Okay.
and they find out that you teach math.
Okay.
What kind of reactions do you get?
Some people, they've kind of studied it a little. Then, yeah, some people say, oh, I don't like math. But it's usually pretty positive. I don't know.
It's usually positive? Oh, that's good.
Yeah.
That gives hope.
No one's like, I hate you.
Why did you choose math?
Oh,
What do you...
why did I choose math? I started as business major. Like the first semester, I remember thinking, oh, I like video games. I want to do computer science. And then at one point, I hit the upper division math, and where it kind of shifts gears into proving things and why are things true and stuff. And then I started to like that.
Most people like me never get that far.
Yeah, it doesn't really get interesting until like the college level. Prove things, let's abstract things. I don't know, it just gets more interesting and then more creative too. Everything's so clean and beautiful.
What makes math beautiful?
I don't know. This is going to be a great interview to see like,
Whatever.
I don't know.
To be fair, nobody's really answered that question.
The beautiful part?
Anybody I asked?
Well, there's like very simple. Let's take number theory for example. Like you could study like the prime numbers. What's cool about that is like you've got this very basic number thing, but then people come at it with like these very abstract tools. That's like a whole field of math that uses these objects to find out properties about normal numbers.
Oh wow.
Yeah.
That's nuts.
I know, right?
What do you like about pure math?
I'm interested in applied math too. I've been wanting to learn more like stats kinds of stuff because I taught probability recently,
Oh, cool.
and I wanted to learn about gambling really. And,
Of course.
So
Isn't that where it started from?
yeah. So I was looking into
Yeah.
history, and it was all they wanted to figure out gambling. I'm interested in applying it. How can you make money, basically?
It's a good motivation. What is math in your personal definition of it?
Oh, okay. What's math? Trying to find patterns and then trying to prove why it's true.
I like that. You're not teaching, you're getting paid to just like try a bunch of random stuff and see if you can prove something.
True, yeah.
It's a little bizarre, isn't it?
It is
It's a weird job.
All the academic jobs are like that. Yeah, you get a lot of freedom.
What are your other main hobbies right now at the moment?
Mostly the art stuff. I've been trying to get back into yoga again because I noticed like I need to stretch more.
How long have you been painting?
I think about 8 years or something. So like this is a copy of Saison. So like that's my dad.
Oh, nice.
And then I did that one after this one. I don't know, for me hobbies kind of, or what I get into kind of, I cycle through it. So
I can relate.
yeah, exactly.
Yeah, hobbies are the best.
I know. That's why I like to have time. My brother's coming to visit. Woo! Christmas time. He lives up in Napa.
Oh, nice.
What were we gonna say about it?
I don't remember. Right. Okay. So Russell and White. So I heard of Bertrand Russell.
They were trying to say, all right, let's find like the axioms that kind of describe sets, and from those we'll just prove all of math. Somebody came along. His name's, I don't know how to say it, Gödel or Gödel.
I think it's Gödel.
Yeah.
That umlaut thing. I don't know. Yeah.
He basically comes along and says, hey, no matter what axioms you start with, then there will always be mathematical statements that you can't prove true or false. They're out of reach from the system.
So that whole big book that they wrote on set theory, just kind of like, this is like, who cares?
They realize, well, I mean, I guess we still use that.
I think set theory is pretty cool, though.
Yeah.
Do you have any like favorite theorems.
I liked the number theory stuff, so like the prime number theorem, I like that. Let's say you pick a number like 1,000. How many primes are there from 2 to 1,000? You could just count them up, right? Like, okay, there's 2, there's 3, there's 5, there's 7.
It would take a while, but
that's
okay.
5 so far. But it turns out like you can estimate it by x over log x.
That's cool. I didn't know about that one.
There's an integral also that estimates it, and then all this math called complex analysis got developed. Once all the machinery was developed, then they applied it to this thing about primes, and they proved that there.
Wow, that's kind of a roundabout way of...
Yeah. Recently I've been learning about, Pythagorean triples.
No, I mean, I know of Pythagoras. What are the triples?
Yeah. So like right triangles, Pythagorean triples are right triangles that have integer sides. So like 3, 4, 5.
Oh, okay.
How many triangles are there?
How many triangles are there?
How many triangles with whole number sides? So like 3, 4, 5.
Is it not, it's not infinite?
It is infinite, yeah. So like you could take 3, 4, 5 and just scale it or multiply by 3, 9, 12, 15.
I don't know.
And those also
mental math is not my strength.
I know, I gotta focus. I'm like, So there are infinitely many. You can actually come up with a formula that pops out all of them. People have figured out like there's multiple ways to do it. They've also found this like recursive tree kind of thing. The base of the tree is the 3, 4, 5 triangle, and then you can use matrices to make 3 branches, and then 3 more, and it pops them all out. It's kind of cool.
Cool. You like math, but how do you feel about arithmetic?
I'm better at it now because in class I don't use a calculator.
I've been trying to get better at that this month.
Yeah, I forgot how to divide for a while.
Like, that's good to know then. You teach math, but you forgot that. Okay, I don't feel so bad.
Yeah.
What about the subtraction one? Do you do it where you like scratch out one of the numbers?
That one I haven't really done that much subtraction lately. I kind of forgot. I think.
Well, now I really feel better. You don't subtract when you're like doing math research.
For some reason, subtraction doesn't happen as much as adding.
At least for me, it seems like adding is easier than subtracting.
Yeah, why is that?
Yeah, you agree with me? Okay, not everyone agrees with me on that.
The adding method is just so much easier. Some person's like, my method will win, and they just like snuffed out all the people. I'm gonna have to subtract more so I get better.
When I get better at it, if I find a cool tip, I'll let you know.
Okay, nice.
What sort of math do you do then? Sitting at your desk, you're doing math. What kind of stuff do you do? Like, so you're not subtracting.
Well, in this expander graph area, there's these things called graphs, a little circle, and then you draw a line between them.
Like nodes?
Yeah, nodes.
That are connected?
Yeah,
whatever.
connected, yeah.
Okay,
so like if you pick the prime 13, there's going to be 13 circles. And then you can connect them with lines based on a certain rule. So they make these things called paleographs. And me and some students were looking at those graphs, and we wanted to measure what's called their expansion constant. It's hard to calculate because it's combinatorial. You have to check like all these things. So we're trying to estimate it. Like the students would write little programs and like try to figure out what the good guess was.
Do you use programming a lot in math?
Yeah, totally. And then once you think something's true based on the computer, then you go, okay, why is that true? Then that's the hard part. You've got to somehow figure it out.
What is the thought process like for you?
You go, okay, I'm trying to see why this is true. I know these other things are true. And you kind of just try everything you possibly can.
Yeah.
Like, all right, what if I try this? And then you see where that leads. And then, okay, that didn't get anywhere. And then you go, well, maybe I could try this. And then you try that, and you see where that goes.
It sounds a lot more like art to me then when you put it that way. Like you're just trying stuff.
Yeah, it's totally open-ended. A lot of math, too, is you learn all these tricks that other people have created. So then you got like a bag of tricks that you try.
I like the bag of tricks.
So you're like, you try all your tricks.
You're a mathematician.
Yeah, exactly. A mathematician. Who is that guy?
There's that guy who...
Art Benjamin, right?
Yeah.
And then most of the time you try your tricks and you don't get anywhere. Then something just stays unsolved for a while.
For hundreds of years.
Until somebody comes up with some new trick.
When you describe it that way, that sounds way more fun.
I don't know if I'm allowed to cheers you with nothing in here. There's like a tiny little bit right there. You see that?
Okay.
I'm allowed to, yes. Cheers.
Cheers and cheers.
And cheers. And cheers.